All right, we're going to go ahead and start our Unit 9 review by taking a look at the review packet at question 1, part A and B. We're going to be finding some missing sides for these triangles. The very first triangle has a base of 3, side of 5, and a hypotenuse of C, and we need to figure out what C is. Now, since we have two sides of this triangle, we can go ahead and use the Pythagorean Theorem in order to figure out the third side, a squared plus b squared equals c squared. Now, the only side that really matters for labeling is c. I need to make sure that c is the hypotenuse. The other two sides don't really matter very much, so I can go ahead and fill them in whichever order I'd like. So 5 squared plus 3 squared is going to be equal to c squared. 5 squared is 25, 3 squared is 9, and when I add those together, I get whatever c squared is, which means that 34 is going to be c squared. So if I want to solve for c, I have to take the square root of both sides. Now, c is equal to the square root of 34, and if you plug that in your calculator, that radical can't be simplified. It just stays as it is. If you would prefer to type it into your calculator and get a decimal, for this question there is no requirement for the answer. If you want the decimal, you are more than welcome to find it. C equals 5.831. Let's go ahead and take a look at the second question here. This is part B. We have another right triangle here. This time we're trying to find this missing side down here on the bottom, right down here. Now again, we have been given the hypotenuse in one of the legs, and the only side that matters is that hypotenuse. I have to make sure that the number 7 is written in the formula where the hypotenuse goes, which is on the right side of the equal sign. The other two I can fill in however I'd like. So 2 squared plus b squared is going to equal 7 squared. 2 squared is 4. I still don't know what b is, and 7 squared is 49. Now if I want to solve for b, I have to get this 4 away from it, so I'm going to subtract 4 from both sides. So b squared is going to equal 49 minus 4, which is 45. And to solve for b, we're going to go ahead and take the square root of both sides. So b is going to equal the square root of 45, which can be simplified. 45 is 9 times 5. 9 is a perfect square, which means I can take the square root of it and bring it out of the radical. So let me go ahead and write that out. 45 is the square root of 9 times 5. I can take this radical, I can take this 9 out of the radical by taking its square root. So I would get 3 and the square root of 5. And your calculator can do that for you. Or if you would prefer, you can type it into the calculator to get a decimal. So this is the answer. Or if you type it into the calculator to get a decimal, it looks like the decimal is 6.708. Either one of those is acceptable for an answer. All right, let's go ahead and move on to finding trig values for a triangle. So this is just finding missing sides. And here in question 2, we're going to be determining trig values for a triangle on the right. We've been given two angles in here, theta and this other symbol down in the corner, which is phi. They're both just Greek letters indicating that we have some missing angles, and these are what their names are. Up first, I have to find the sine of theta. To find the sine, cosine, or tangent, I have to use SOHCAHTOA. So to find the sine of theta, I have to recognize that the sine is the opposite over the hypotenuse. That's what this equation means. The opposite from theta is the number 8. The hypotenuse is over here. It's the number 10. So the sine of theta is just 8 over 10, which I can simplify. Both of these are divisible by 2. It's 4 over 5, and that one's all done. Let's go ahead and try to find a cosine. The cosine of theta is going to be the adjacent over the hypotenuse. The adjacent's over here. So it's going to be adjacent over hypotenuse, which is 6 over 10, and I can reduce that to 3 over 5. Last but not least, I have the tangent. Here we go. I have the tangent over here. Tangent is opposite over hypotenuse. So the opposite was this side. The hypotenuse is, not over hypotenuse. Mrs. Purvis. It's the opposite over the adjacent. That's what this A stands for over here. So, not the hypotenuse. Nope. It is the opposite over the adjacent. So 8 over 6, which is going to be 4/3. So we have found all of these trig angles for theta. Now let's go ahead and take a look at doing the same thing for phi. So the sine of phi. This time my angle is on this side, so its opposite is this guy over here, 6. So to find the sine of phi, I have to use the opposite over the hypotenuse, so 6 over the hypotenuse of 10. So it would be 3/5 for the sine. To find the cosine, I would need the adjacent, which is right over here. The adjacent over the hypotenuse, which is 8 over 10, which simplifies to 4/5. And to find the tangent, I would need the opposite over the adjacent, which is 6 over 8, which simplifies to 3/4. All right. Let's go ahead and take a look at question 3. Question 3 is in a similar vein of question 2 and question 1 combined. Let's go ahead and see what it says. For the right triangle shown, what is the sine of angle B? So my angle is right over here, and I'd like to find its sine. Remember, the sine of an angle is the opposite divided by the hypotenuse. So if this is my angle, the opposite is this side right over here, and the hypotenuse is the number 16. So the sine of B is whatever this side is, x, divided by the number 16. The problem is I don't know what x is, and I can't find the sine of B until I know what x is. So what we're going to have to do is calculate this value. And we have two sides of this triangle, so we're going to do it using the Pythagorean Theorem. Again, the hypotenuse has to be the c value. The other two are interchangeable, x squared plus 14 squared. All right, so x squared plus 14 squared is 196. Is going to equal 16 squared, which is 256. I'm going to go ahead and get x alone by subtracting 196 from both sides. So x squared is going to be equal to the number 60. And I can take the square root of both sides to solve for x. So x equals the square root of 60. Now this can be reduced. 60 has a perfect square inside of it. 60 is 15 times 4. So this 4 is a perfect square and can be taken out. So x is actually 2 times the square root of 15. And 15 has no more perfect squares left. It's just multiples of 3, 8 times 5. Your calculator can also simplify this radical for you. So this is what x is. So we're going to go ahead and plug this value in to this equation where we see x. So the sine of b is going to equal 2 times the root of 15 divided by 16. And all we have to do to finish this problem is just simplify this fraction. 2 and 16 have a GCF of 2. 2 divided by itself is 1. 16 divided by 2 is 8. So our final answer for the sine of b is going to be 1 times the root of 15, which is just root of 15, divided by 8. And that one's all done. We're going to go ahead and pick up with question 4 in the next video.